I thank the technology which has come in such a profound way to a person like me to be able to express my ideas. This technology is actually helping me to express myself, my ideas, whether be it the ideas right or wrong is a test of time. And I present certain ideas and the scientific community will prove me wrong if I am wrong, and they will appreciate if I am right. And what I am going to take with me is the delight which I get by sharing these ideas with the rest of you. Okay, I'll tell you this in a story way. Okay, so considering the solar system, it is convenient to understand the formation of the solar system or the present existence of the solar system as the inner and outer solar system, which we all know or familiar. Why is that? Because you look at these bodies, the inner solar system comprises of solid bodies called Mercury, Venus, Earth and Mars, and Earth has got a natural satellite, the single body to have such a large satellite, 1/6 of the mass of the Earth, which is also having a solid surface as Earth going around the Earth. And it's an unusual object in the whole solar system, Earth and the Moon. And you look at Mars has got two small satellites, irregular, if I may say, used potato-shaped bodies, which are asteroidal type of bodies going around Mars, the very small ones. When it comes to Jupiter, there's a lot more distance in between Mars and Jupiter than there is distance between Venus and Earth or Earth and Mars. So that distance had been an enigma, and Gaius Paiussi discovered the asteroid Ceres in that space, and then Pallas, Vesta, Juno and Vesta have been discovered, and many thousands of asteroids have been discovered in the gap between Mars and Jupiter, and thousands of asteroids comprising into belts, around this sun, which is existing now. But when you come up to Jupiter, it's an enormous system in itself. It has got two and a half times the mass of all the planets put together, and still it forms less than a minute percent of the remaining 1% of the mass of the solar system itself. Jupiter takes up an enormous share among that 1% mass. The rest of the mass is gone, 99%, and more than that mass is there in the sun. And the remaining 1% of mass, Jupiter has taken a lot, and the left is formed by the other planets. And then Saturn. Jupiter and Saturn are called gas giant planets, and Uranus and Neptune are called ice giants. But even though they call it ice giants, they are also gas giants of a lesser size than Jupiter and Saturn. See, these planets are essentially formed by a process called collisional accretion. Due to gravitation, universal gravitation, the primordial solar nebula started to fall inside as the nebular matter was condensing from all directions due to this gravitation of the entire gas cloud, which contained predominantly hydrogen, helium, and then a trace amount of other elements. They started shrinking towards a denser center of as the rotating gas cloud started shrinking from all directions 360 degrees. It caused such infalling matter of various densities, like gigantic comets falling towards the center of the solar system. They come even now from the outer fringes of the solar system. Such gigantic concentrations of matter, as it was falling inwards towards the center of the solar system, attracted each other and produced a differential gravitational thrust and made this enormous gas cloud to rotate around, defining an axis of rotation. And what about their satellites? What about the inner solar system? Did it also form similarly by cold accretion, or was it something different? Why is it so characteristically different then? Why is the Earth like solid surface? Why is Venus so different? All having solid surface, the densities are very high. And look at Jupiter and Saturn, the densities are very low. So why fundamentally? My understanding is that the objects is formed by collisional accretion or gas giant bodies. And the sun is also a gas giant body. But why is it so different from the planets then? Why do we call Jupiter a failed sun? Is it a misnomer? Is our understanding? Yes, even to form a small red dwarf star, it has to have 10 times the mass of Jupiter to be, many times the mass of Jupiter to initiate into a star. When that is the case, we can hardly say that Jupiter is a failed sun, because it's far short of becoming a star like our sun, present day sun, which it is powered by nuclear reactions. Fusion reactions occurring in its core. As we understand, it was discovered by Hans Albert Bethe in 1930 that the sun is powered by fusion reactions inside its core. It is 4.5 billion years old planetary system. It's almost 5 billion year old planetary system in which the sun has lost half of its mass. It is supposed to last for another 5 billion years by the astrophysicists, they say. And naturally, its gravitation would have been reduced to half from its original, because it's spending its energy and it dissipates, its matter is getting reduced, isn't it? And therefore, even with the days to come, the sun will swell up and it will lose its matter and it will lose its gravity, therefore it will swell up. And the planets will no longer be orbiting in the present distances. It will go away from the sun because of the lesser gravity. It's just the law, gravitational law. So you go back in time and see that at the time of 4.5 billion years ago, when the solar system was forming and predominantly all the matter was falling towards the sun and forming the sun, the less than 1% defined it to a protoplanetary disk, and which is forming the gas giants, particularly in the outer fringes of the solar system, the outer part of the solar system, where Jupiter, Saturn, Uranus and Neptune were forming into separate miniature solar systems. Do they not look like separate miniature solar systems? Saturn and Jupiter, Saturn with its ring system, like an asteroidal belt around the sun with its satellite systems, exactly above their equators. You know what the equator is? The equator divides an object into northern and southern hemispheres, and it's perpendicular to the axis of rotation. The sun has an axis of rotation. The inner planets, Mercury, Venus, exactly on the sun's equator. When you look at Earth is 7 degrees away from, there is a inclination, what you call as inclination, right? So when in the times when positional astronomers had been observing the night sky, they took the Earth's orbital plane around the sun as the standard. Well, that kind of misleading, we should actually have taken something like Jupiter, which is exactly orbiting around the solar equator, or Mercury for that matter. Earth is tilted 7 degrees from the solar equator, possibly because of the co-development of the moon. That could have caused some inclination. That's what I feel. When moon also formed, that Earth could have tilted inclined some 7 degrees. And we have the various planets with different eccentricities, highly elliptical orbit, and some are not as elliptical as some planets are. Mars, for example, has a highly elliptical orbit. It comes almost half the distance every time. Orbital motions have been defined by Kepler's laws, and Mars comes very close at times and goes very far, because it is a highly flattened orbit, highly elliptical. Eccentricity, we say eccentricity is very high in the case of Mars. So Jupiter, for example, it is not a planet which is tilted much. Its axis is almost parallel to the sun, and it's very far, and it has a ring system which is very faint, which is discovered by the Voyager spacecraft, and it has got many large satellites and irregular satellites going around, and number of these satellites seem to be increasing nowadays. With our technology, we are detecting increasingly more number of asteroids, and Saturn has got the largest number of moons than Jupiter. How could this be possible? What is our understanding of the whole thing? What do we call as? We start calling them as regular satellites, irregular satellites, and we say natural satellites and artificial satellites. That's understandable. Moon is a natural satellite, and our spacecraft launched systems are artificial satellites around the moon. But how could there are regular and irregular satellites? Scientists say, and what is this? Regular satellite is a well-defined structure, like the moon, which is with a spherical structure, right? So you call it as a natural satellite, a regular satellite in a perfect orbit, nearly circular orbit around the parent body, right? And an irregular, potato-shaped irregular body is a very small size, so only several kilometers. These bodies are called irregular satellites, and they are asteroidal type of bodies going, and they don't seem to fall exactly around the equator of the parent bodies. Most of them are, but a few of them keep traveling in highly inclined orbits at more than 60 degrees, 40, so many orbits, and some of them even go retrograde. That puzzles. So these are the oddities, the enigmas of the solar system, for example. So these Venus and Saturn, I mean Uranus, and these bodies, why it should be so tilted. So these various presentations makes us ponder about a general scheme of things from which from the chaos an order emerged, and over a period of billions of years accidents are possible. There could be many things that could be attributed to the odd behavior of these bodies. That's what we are trying to understand.